Until now, we were learning Pandas features. In this video, we stop learning features and start thinking like a real data analyst. Real datasets are like not clean, not small, and not fast. Okay, so there are large, messy, confusing, and that's where Pandas is actually tested. Okay, so in this video, I will show you how professionals use Pandas on real-world large datasets, not toy samples. And this is Pandas Advanced Part 9. Okay, now we will use a real HR analytics dataset from Kaggle. This dataset has realistic columns, thousands of rows, and real business meanings. This is kind of data used in companies, not tutorial data. Okay, so I provided the dataset link inside this, and also I will be providing it in the description. So you can also see that the employee attrition CSV file also loaded in here. Okay, so first of all, we need to load pandas and we need to read the CSV file. Okay, as we always do, we import pandas as PD, and afterwards we place df equals pd dot read CSV and the name of the file, which is HR employee attrition. And also, we need to add something more, which is low memory false. Okay, so provide a comma after that and then give low memory false. Okay, so when datasets are large, Pandas reads files in chunks to save memory. Because of this, Pandas may guess column types incorrectly, for example, mixing numbers and text. Okay, so low memory equals false. This code, which is placed here, is telling the pandas that take a little more time but read the file correctly. Okay, don't mess it with the numbers or anything. Please read everything correctly and efficiently. Okay, in such cases we use low memory false. Okay, and this prevents hidden bugs later in analysis. Okay, so you get what's low memory? That is control how pandas reads large files in chunks. Okay, so that's what our low memory does here. Okay, where to place? We place next to the read file. Okay, the file name or the dataset name. Okay, then the first rule in real analysis, as we already discussed about that. Okay, first of all, we can run this and it will run properly. Afterwards, we take our first rule, that is df.shape. We need to know the shape of pandas for the dataset. And we also need df.info with memory usage equals deep. We can place deep in quotation. Okay, now the professionals don't scroll data, they measure it first. Okay, for that we use shape. The shape tells us how big the dataset is, the rows and the columns. It shows the dataset numbers, the column number and the row numbers. Okay, then we move to the info. As we already discussed about info provide many details like how many columns, the memory usage, which data type is used in each column, the name of each column, all this. Okay. Now, it shows a lot of things, including the missing values, column types, all this. For that, we used info. And in this part, advanced, we are using memory usage as deep. So it is new to us. Also, in the previous time, we also used memory usage as deep, but we didn't explain what is that. Okay. In pandas, by default, pandas gives only an estimate of memory usage. So deep tells pandas to fully calculate the memory and especially for the next columns like object or string. Okay, the character columns. So this is important because test columns secretly consume a lot of RAM. So deep tell us to pandas to calculate the memory, especially for such columns with characters. Okay. In in the other way, we can say like df dot memory usage, but deep equals true is the most accurate way of real data sets. Like, just don't take it a lot. Let's just say we use deep because the pandas should read and consider the memory of the characters, the string, the object, all are same. So these things, okay. For that, we use the memory usage as deep. So it will deeply go through the data set and find the overall memory. Nothing more or nothing less. Okay. In large projects, memory awareness matters. So while we are talking about hard projects, we should really know how memory works and where to add deep. Because of that, we explain all this much slow. Okay. Now we need to reduce the memory. For that, in the last time, we converted the department into categories. This time too, we are doing the same. But we are also using the attrition with map. That might be a little bit new for you. We can run this, and this is where advanced pandas begins. Okay, so the category. A category is a special data type used when values repeat. As we say, if we have uh, like HR several times, data analyst several times, so we keep it like a number. If HR is considered as one, data analyst will be considered as two, like that. Okay, so while we have repeated department names or some kind of things like business names or business or anything which is repeated, we use the word category. Okay, so it will help us to reduce the memory, and instead of storing the same test again and again, panda stores a code internally. So this saves memory and makes operation faster, as we already talked about it in our last classes. So don't let it be confuse you, or it's just say to make you clear why we used category here. Okay, and map. So we already talked about map though, but to refresh, the map converts test labels into numbers. Okay, now yes becomes 1 and no becomes 0. Numerical data is faster and easier to analyze and require for many calculations. So we use map and convert the attrition. So if there are S, it will be like 1, no, it will be like 0. So that's why we use map, which really converts the test labels into numbers. If we do df, we can find the difference. Now, there are attrition. We can find attrition where you can find yes for 1 and no for 0, all this. Before that, we need to understand how it's like before all this. We didn't run the df here, so we can run it and add a chord set df. So here there are yes, no, all this. So it is already changed because we already run the last code. So the total one will be changed. Okay. And before moving, here I added a parenthesis, but we don't need parenthesis here. We just write df.shape. Okay. While you code, you may get an error. So sorry for that. So this is how it works. And so while I go through the code, I realize that why it get nan instead of the numbers. Here we saw it's yes, no, all this. But when it comes to here, we asked it to say map this to 1 or 0 if yes or no. But still it changes to nan. It says like not a number. That means attrition is not a string but a integer. So let's find attrition here. And now look, attrition is an integer with integer 64 bytes. Okay, so we understand that the reason for the nan. So there are several codes we can use, but for now, let's just remove the codes and let's try. Okay, let's give it a shot. So yes is not defined and it says so. So what can we do instead of this? Can we just use replace? So here we use replaced, but the reason or the mistake we done is if we use it like we can use this as string, run this. Okay, what happened? And run it again here. So we get the attrition as 101. So the yes no is now changed to 1010. Okay. So here we used replaced instead of map. Okay. And as we know, map is convert the test labels into numbers. Replace can replace the words, like if there is yes or no strings, we can change that to 1010. Okay, that's how it works. So if you find any error, you can comment below so I can explain the error you are facing. Okay. Now we are moving to real filtering in business logic. Okay. So first of all, I need to create the high risk variable name with df dot log, open then df attrition, which is equals to 1, is assigned to 1, and then df monthly income. We need to place monthly income, and which is less than 5,000. Okay. And we are using another and then df, we need to give job satisfaction, which is less than or equal to 2. Okay, then run. So as you see here, this is not random filtering. We are asking a real question. Who is likely to leave the company? We can understand who might leave the company soon, or what is the reason behind that? Is it behind the reason is the low income or the low job satisfaction? We can understand this by taking high risk. Okay. So business logic is like filter that answers to the real world question. In real world, people need to know the HR need to know who might leave the company soon, who will stay, all this, and what is the reason for that. Okay, so this is how it looks like the first five. So while you go to the attrition, which is equal to 1, or the income, all this can be seen here. So in high risk data, we found the def dot location, and so what we really get, we miss our brackets. So our output just look like different than this. Now it's much more clear. Like it show the precise values when attrition is only equals to 1, when the monthly income is less than 5,000, or the job satisfaction is less than 2. All this can be seen here. Okay, as we said above. So, this is how the business logic is explained. It will answer the real questions that is asked by the HR or the main people in our crew. Okay. Now, we need to go through the group by. So, I will just write the code afterwards. I will explain. So, now I type the code, and here we placed it in under the summary. And groupby is not about syntax, it's about decision. We are comparing departments by income, attrition risk, and employee count. So we provide aggregation with average income, attrition rate, count, and the monthly income. The average income will be taken as the monthly income average. The attrition rate will be taken as the attrition average, and then count will be taken as the average of employee number. Okay. So afterwards, we sort the value, we place the ascending as false. Okay, that's all what we do here. So this is exactly how analytic dashboards are built. So aggregation tell us calculate multiple metrics at once with clean and readable way. So because of that, we use aggregation, which will help us throughout this process. Okay, now we need to use the Windows function. Okay, last time we used rolling. Now we are using that again in this code. So this is our part 9. So we are just doing it in advanced way. So DF, we are placing income trend. Afterwards, we need which is equals, open the bracket, TF dot group by, add department. Also, we need the monthly income. And we are giving dot rolling with 5, also dot mean, and then dot reset. So reset index, we can give level equal 0 with drop equal true. So Windows function analyze trends, not just totals. Rolling means smooth, noisy data. As we learned yesterday, this shows income trends inside each department. And as we talk about rolling, it is a calculation over a window. We provide 5, so that's our window. Provide df again, we will find all this. And window function which calculate the across neighbor rows. We can find the calculation across the different rows which is aligned nearby. Okay, so as we learned about rolling, it take the average, it gives a smooth way and readable way of data, all this. And try to avoid apply, okay, because as we say, it's a bit confusing than the other things, okay. So while you go through this, and you may find the income trend as nan, and you may be confused why it comes this way, because we gave first 5 as the rolling count, and if we use df dot head, inside that we can give 6 or just 10, run this. So you can find that the sixth one is the average of the rest 5. Okay, it calculates the average of rest 5 and giving given in sixth one. So as we know how rolling works, it's do this way. Okay, now we are moving to vectorization. That is df use low income flag. Afterwards, we need monthly income df which is less than 4,000, and we need to provide dot as type int. Okay, so many beginners use apply everywhere, and they don't even know why we used it. So here we use vectorization instead of apply, because apply loop row by row, slow on large data, but in vectorized operations work on whole column at once and much more faster. We talk about apply, vectorization, all this, you know. And why we say in a line, vectorization is like column-wise operation without looping, not just like apply. Apply use loops, row by row, all that, and slow it down. So we take vectorization. Now our final insights. That's summary.head and high risk.shape. We need to find summary.head and okay. So analysis without a conclusion is useless. We also always need conclusions while analyzing. So always at end, by answering what did we learn, what should the business do, all these questions, all the questions you have in your own mind. So answer the questions, find the questions, ask the questions in your own way. Like while you want to know something, you just need to ask it, and you can find some ideas and apply it. If you get an error, just don't stop there or pause, just pause there, don't stop, and you can mention that in comment. I will take a video about the corrections or the bugs you may have while you were coding in your own pace. Okay, so advanced pandas is not about more functions, it's about more efficiency, clean logic, readable pipelines, and answering real questions. That's what advanced pandas is. So in the next part, we will go through end-to-end pandas projects with large data, clean in a clean notebook, all this. Okay, so you can place also in your resume how you done all these things on your own. Okay, so that's all for today, and thank you for listening. Bye bye.